Good morning, students. Welcome to another video of physics class for grade 11. Let's recall the previous class portion. The previous class, I explained about the elementary concepts of vector algebra. In that, you have learned about scalar and vector quantities. Scalar quantities means it possesses only the magnitude. Distance, mass, temperature, speed, etc. are the examples of scalar physical quantities. Vector quantity, it is a quantity which is described by both magnitude and direction. Force, velocity, displacement, linear momentum, etc. are the examples of vector quantities. Next, magnitude of a vector, that is nothing but the length of a vector. Also, we learned different types of vectors. What are the different types? Equal vectors, collinear vectors, parallel vectors, anti-parallel vectors, unit vectors, and orthogonal unit vectors. Then we have discussed about the addition of vectors. When the two vectors are inclined at an angle, we have to follow two methods for addition. That is triangle law of addition and parallelogram law of vectors. So triangle law of addition we have learnt. What is triangle law of addition? Represent the vectors A vector and B vector by the two adjacent sides of the triangle taken in the same order. Then the resultant is given by the third side of the triangle. So the magnitude of the resultant vector R is equal to root of A square plus B square plus 2AB cos theta. Alpha is equal to tan inverse of B sin theta by A plus B cos theta. This is the direction of the resultant vector. Similarly, we have discussed about the subtraction of vector. That is, subtraction means adding the negative vector to the first vector. There also we got the resultant vector magnitude is A minus B equal to root of A square plus B square minus 2AB cos theta, and alpha, it is alpha 2 equal tan inverse of B sin theta by A minus B cos theta. And I told you to do the problems 2.1 and 2.2 from the book. I hope you all have completed. Let's move on to the today's topic. Today I am going to teach components of a vector. Components of a vector. Any vector can be resolved into three components along x, y, z directions. That is, in the Cartesian coordinate system, a particular vector can be resolved into three components along x, y, z directions. Consider the two-dimensional system. This is x-axis and this is y-axis. So this is a vector A. This vector component we can write in terms of Ax and Ay. Ax is the x component of A vector and Ay is the y component of A vector. It is obtained by drawing the line from this vector to the x-axis as well as to the y-axis. So this is the x component of A vector and this is the y component of A vector. So we can write A vector is equal to Ax I cap plus Ay j cap, where I cap and j cap are the unit vectors along the x and y axis. In case of three-dimensional coordinate system, we can write the A vector. That is Ax I cap plus Ay j cap plus Az k cap, where Ax is the x component of A vector, Ay is the y component of A vector, and Az is the z component of A vector. See this figure. So this is the x-axis, this is the y-axis, and this is the z-axis. This is a three-dimensional Cartesian coordinate system. So the A vector can be resolved into three components. Let us see, this is the position of the particular object. So P of x comma y comma z. Here first you consider the xy plane. This is xy plane, this is yz plane, this is xz plane. Xy plane, yz plane and xz plane. So the A vector component along the y-axis is ay. A vector component, that is x component, is ax. Now resultant of these two vectors actually acting this direction. Okay. Now from this is the z coordinate. This is the z coordinate. This is the position of the object. So z component, that is az is acting here. So for this position, this is the y distance of this position, this is the x distance of this position, and this is the z distance of this position. So this is a three-dimensional Cartesian coordinate system. We can resolve the A vector into three components: ax I cap plus ay j cap plus az k cap. If A vector makes an angle theta with the x-axis, if A vector makes an angle theta with the x-axis, ax and ay are the components of A vector along the x and y axis. We can write ax equal to a cos theta, ay equal to a sin theta. That is, this is x-axis and this is y-axis. So this is the A vector which makes an angle theta with the x-axis. So we know that this is the ax component, this is the ay component. What is the value of this? Drawing a perpendicular line from this vector to this axis and perpendicular line from this vector to this y-axis. From this figure, tell me the value of cos theta. Cos theta is equal to adjacent side by hypotenuse. So ax by a. From this, ax is equal to what? A cos theta. Again, from this figure, what is sin theta? Opposite side by hypotenuse. Opposite side is similar to this ay. So we can write ay. Ay by hypotenuse is a. So we can write ay is equal to what? A sin theta. So x component of a is cos theta component. Y component of a is sin theta component. So A vector is the vector. Its magnitude A can be written as A equal to square root of ax square plus ay square. How is it? Listen, in this figure, using Pythagoras theorem, we can write a square is equal to ax square plus ay square. This is ay, this is also ay. So we can write a square is equal to ax square plus ay square. So what is a? Square root of ax square plus ay square. So this is the magnitude of the A vector. So we have seen the components of a vector. In 2 dimension, ax I cap plus ay j cap. In 3 dimension, ax I cap plus ay j cap plus az k cap. The magnitude a can be written as root of ax square plus ay square. 3 dimension we can write plus az square. Alright. Let's move on to the problem example 2.3. What are the unit vectors along the negative x direction, negative y direction and negative z direction? What are the unit vectors along the negative x direction, negative y direction and negative z direction? See here. So this is the x axis. This is the y axis. This is the z axis. Already we have discussed the I cap is a unit vector along the x axis. J cap is a unit vector along the y axis. K cap is a unit vector along the z axis. These all are positive. The question is negative x direction. Unit vectors along the negative x direction, negative y direction and negative z direction. So negative of this x direction is this side. So unit vector is here. Can be written as minus I cap. This is minus x. Negative of y direction is here. That is minus y. So unit vector is this one. Minus j cap. Negative of z direction is here. Minus z. So unit vector is this one. Minus k cap. Unit vector along the negative x direction is minus I cap. Unit vector along the negative y direction is minus j cap. Unit vector along the negative z direction is minus k cap. Now, vector addition using components. Vector addition using components. Once we choose a coordinate system, the addition and subtraction of vectors becomes easier. If we choose a coordinate system, the addition and subtraction of vectors becomes easier. Consider the two vectors a vector and b vector in the Cartesian coordinate system. Two vectors a vector and b vector. A vector can be expressed as ax I cap plus ay j cap plus az k cap. B vector can be written as bx I cap plus by j cap plus bz k cap. Then what is the addition of these two vectors? A vector plus b vector. That is equal to the adding their corresponding x, y and z components. That means ax plus bx into I cap plus ay plus by into j cap plus az plus bz into k cap. So adding the two vectors is equal to the adding their corresponding x, y and z components. The subtraction of two vectors also the same method. Subtracting the corresponding x, y and z components. So we can write a vector minus b vector equal to ax minus bx into I cap plus ay minus by into j cap plus az minus bz into k cap. Let's see the example 2.4. Two vectors are given. A vector equal to 5 cap plus 7 cap minus 4 cap. B vector equal to 6 cap plus 3 cap plus 2 cap. They are asked to find A vector plus B vector plus A vector minus B vector minus A vector. Solution. A vector plus B vector equal to, that is 5 cap plus 7j cap minus 4k cap plus 6i cap plus 3j cap plus 2k cap. So we can write 5 plus 6, 11i cap plus 7 plus 3, 10j cap. Then minus 4 plus 2, minus 2k cap. I 5 plus 6, j 7 plus 3, k minus 4 plus 2. Let's find b plus a, that is 6i cap plus 3j cap plus 2k cap plus 5i cap plus 7j cap minus 4k cap. Here also 6 plus 5, 11i cap. And 3 plus 7, 10j cap. 2 minus 4, minus 2k cap. So from this we can write a plus b equal to b plus a. Let's find a minus b. 5i cap plus 7j cap minus 4k cap minus 6i cap plus 3j cap plus 2k cap. So 5 minus 6, what is that? Minus 1. So minus I cap. 7 minus 3, 4. 4j cap. Minus 4, minus 2, minus 6k cap. So a minus b is minus I cap plus 4j minus 6 cap. Let's find b minus a. 6i cap plus 3j cap plus 2k cap minus 5i cap 7j cap minus 4k cap. So 6 minus 5 is I cap 1. 3 minus 7 is minus 4j cap. 2 minus into minus plus. So 2 plus 4 is 6. 6k cap. So look at this, a minus b minus I cap plus 4j minus 6k. B minus a, I cap minus 4j plus 6k. So here a minus b and b minus a are opposite to each other. Minus I plus a. Plus 4 minus 4. Minus 6 plus 6. But a plus b equal to b plus a. But a minus b can be written as minus. That is, it is not equal to b minus a. That is minus of b minus a. This is opposite direction. Next, multiplication. First, multiplication of vector by a scalar. Multiplication of vector by a scalar. Consider the vector a. A vector is multiplied by a scalar quantity lambda. We will get lambda a vector. That is, the result is another vector. The result is another vector. If a vector is multiplied by a scalar, we will get a vector quantity. If lambda is positive, lambda a is in the direction of a vector. If lambda is negative, lambda a is opposite direction of a vector. In physics, certain vector quantities can be defined as scalar times another vector quantity. Okay? For example, force. Force is a vector quantity. Force can be expressed as mass into acceleration. Here, mass is a Scalar quantity. Acceleration is a vector quantity. So, force is a vector quantity. It is obtained by scalar multiplication of a vector. M is always a positive scalar. So, the direction of force is in the direction of acceleration. Second example, linear momentum. P vector is equal to mv vector. That is P equal to m into v. Here also m is scalar, v is vector. So direction of the linear momentum is in the direction of the velocity. Next, one more example. The electric field force can be written as charge into electric field, Q into E. Here Q is scalar, Q is charge. Charge is scalar, E is the electric field. Charge can be either positive or negative. So direction of force is correspondingly either in the direction of A or opposite direction of E. If the charge is positive, charge can be either positive or negative. So accordingly the force can be either in the direction of E or opposite direction of E. So we have seen multiplication of vector by a scalar. The result is another vector. Let's see scalar product of two vectors. Scalar product of two vectors. Otherwise we can call it as dot product of two vectors. Definition. The scalar product or dot product of two vectors is defined as the product of the magnitudes of both the vectors and the cosine of the angle between them. See, consider two vectors A and B having an angle theta between them. Then their scalar product can be defined as A vector dot B vector equal to AB cos theta. A dot B equal to AB cos theta. This is the scalar product. Now see the definition. Scalar product of two vectors. That is A dot B. Scalar product of two vectors. That is dot product of two vectors is equal to the or is defined as the product of the magnitudes of both the vectors. That is A and B. Product of the magnitudes of both the vectors and the cosine of the angle between them. Cos theta. Cosine of the angle between them. This is known as scalar product. So scalar product of two vectors is defined as the product of the magnitudes of both the vectors and the cosine of the angle between them. So A dot B equal to AB cos theta. A dot B equal to AB cos theta. Let's see the properties one by one. Properties of scalar product. First, the product quantity A dot B is always a scalar. A dot B is always a scalar. If theta is less than 90 degree, that is the angle between the vectors is acute, then the scalar product is said to be positive. If theta lies between 90 degree and 180 degree, greater than 90 degree, less than 180 degree, that is the angle between the two vectors is obtuse. Then the product is negative. This is the first point. The product quantity A dot B is always a scalar. It is positive if the angle between the vectors is acute. It is negative if the angle between them is obtuse. Second property. the scalar product is commutative. The scalar product is commutative. Commutative means A dot B will be equal to B dot A. A dot B equal to B dot A. Both the scalar product are same. A dot B equal to B dot A. Third property. The vectors obey distributive law. The vectors obey distributive law. That is A vector dot B vector plus C vector equal to A vector dot B vector plus A vector dot C vector. A dot B plus C equal to A dot B plus A dot C. The vectors obey distributive law. A dot B plus C equal to A dot B plus A dot C. Fourth one, that is we have A dot B equal to AB cos theta. From this, the angle between the vectors theta, that is cos theta, can be written as A dot B by AB, or else theta is equal to cos inverse of A dot B by AB. The angle between the vectors theta equal to cos inverse of A dot B by AB. So first point, A dot B is always a scalar. It is positive if theta is less than 90 degree. It is negative if theta is lying between 90 degree and 180 degree. Second point, the scalar product is commutative. A dot B equal to B dot A. Third point, it obeys distributive law. A dot B plus C equal to A dot B plus A dot C. Fourth point, the angle between the two vectors theta is equal to cos inverse of A dot B by AB. Let's see the next point. Suppose theta equal to 0 degree. Then cos 0. What is cos 0? Cos 0 is 1. So the product becomes A dot B equal to AB cos 0 is 1. So this is the maximum value. That is A dot B has the maximum value when cos theta equal to 1, that is theta equal to 0 degree. That means the vectors are parallel. The vectors are parallel. So cos, the maximum value is 1 for 0 degree. The maximum value of cos is 1. That is for 0 degree. Cos 0 degree is 1. So A dot B is equal to AB cos 0. So AB into 1. So A dot B has the maximum value that is equal to AB when theta equal to 0 degree. Theta is 0 means the two vectors are said to be parallel. Next point. Suppose theta equal to 180 degree. What is cos 180 degree? Cos 180 degree is minus 1. So the product, scalar product A dot B is equal to AB into minus 1. That is equal to minus AB. So we can call this as the minimum value. Minimum value. The scalar product of two vectors will be minimum when cos theta is equal to minus 1. That is theta equal to 180 degree. Now the vectors are anti-parallel. Vectors are anti-parallel. Next point, it is 7th point. Theta is equal to 90 degree. What is cos 90 degree? Cos 90 is 0. So, A dot B value becomes 0. If two vectors A vector and B vector are perpendicular to each other, that is 90 degree, then their scalar product A dot B equal to 0. So we can say A and B are said to be mutually orthogonal. If two vectors A vector and B vector are perpendicular to each other, that means theta equal to 90 degree, cos 90 is 0. So scalar product A dot B equal to 0. So we can say the vectors are said to be mutually orthogonal. Let's move on to the next point. The scalar product of a vector with itself. The scalar product of a vector with itself is termed as self dot product. Self dot product. That means given by A vector square. That is A vector dot A vector can be written as AA cos theta. A dot B equal to AB cos theta. So A dot A equal to AA cos theta. Here both are A and A. So what is theta value? Theta value is 0. So we can write AA cos 0, that is A square. So A vector square is equal to A dot A, or else the magnitude or norm of the vector A vector is equal to square root of A dot A. That is the modulus. The magnitude of the vector can be as modulus A vector equal to square root of A dot A. So what is the 8th point? Self dot product. It is the scalar product of a vector with itself is termed as self dot product. It is given by A vector square. That is A dot A equal to AA cos theta. Here the angle between A and A is 0 degree. So AA cos 0, that means cos 0 is 1. So A square. The magnitude A square is A dot A. So what is A? Square root of A dot A. The magnitude or norm of the vector can be written as square root of A dot A. Listen, with theta concept we have seen 4 points. Theta equal to 0 degree, cos 0 is 1. So A dot B has the maximum value. The vectors are said to be parallel. Theta is equal to 180 degree, cos 180 is minus 1. So A dot B has the minimum value minus AB. Vectors are said to be anti-parallel. Theta is equal to 90 degree, cos 90 is equal to 0. So A dot B equal to 0. Two vectors are said to be orthogonal. Then self dot product. That is theta equal to 0 degree. So A vector square equal to A dot A. That is A vector square equal to A dot A. The magnitude of A vector is modulus A equal to root of A dot A. Next point. In case of a unit vector n cap, that is n cap dot n cap is equal to, unit vector means 1 into 1. So n cap dot n cap means nn cos theta. Theta is 0. So we can write 1 into 1 into cos 0. That is nothing but 1. Actually, we can write I dot I is equal to 1. J dot J is equal to 1. K dot K is equal to 1. So in case of unit vector, I dot I equal to 1, j dot j is equal to 1, k dot k equal to 1. Next point. In case of orthogonal unit vectors, in case of orthogonal unit vectors, that is I, j and k. I dot j equal to j dot k equal to k dot I is equal to I and j. The angle between I and j is 90 degree. J and k, the angle between j and k is 90 degree. K and I, the angle between k and I is 90 degree. That is orthogonal vectors. So we can write unit vectors 1 into 1 cos 90 degree, that is equal to 0. So I dot j is equal to 0, j dot k is equal to 0, k dot I is equal to 0. In case of unit vectors, I and I is equal to 1. In case of orthogonal vectors, I and j or I and k is equal to 0 degree. In terms of components of the scalar product, that is, we know component, what is that? A vector can be written as ax I cap plus ay j cap plus az k cap. B vector can be written as bx I cap by j cap plus bz k cap. So in terms of the components of scalar product, A dot B is equal to ax I cap plus ay j cap plus az k cap dot bx I cap plus by j cap plus bz k cap can be written as I and I, j and j, k and k equal to 1. I and j, I and k 0. J and I, j and k 0. K and I, k and j 0. So only the common we will get ax bx, I into I 1 plus ay by, j into j 1 plus az bz. The all other terms are 0. Ax bx plus ay by plus az bz. Other terms such as ax by, ay bx, az bx, all other terms are 0. So the magnitude of vector A is given by modulus A is equal to root of ax square plus ay square plus az square. So these are the properties of scalar product. Very important question. Properties of scalar product. 11 points are there. Just we can recall. First, the definition A dot B equal to AB cos theta. The properties, always A dot B is scalar, then less than 90 degree product is positive. Greater than 90 degree, less than 180 degree, product is negative. Then it is commutative, it obeys distributive law. Then theta value, cos inverse of A dot B by AB. Then when theta equal to 0, A dot B has the maximum value. Theta equal to 180, A dot B has the minimum value. Theta equal to 90 degree means vectors are said to be orthogonal. Then self dot product. This A dot A cos 0, that is equal to A square. In case of unit vectors, I dot I, j dot j, k dot k equal to 1. In case of orthogonal vectors, j dot k dot I is equal to 0. So in terms of component, the scalar product A dot B is written as ax bx plus ay by plus az bz. Students, you have to learn the question, discuss the properties of scalar product. Very important question. Let's move on to the example 2.7. Given two vectors A vector equal to I cap plus 4j cap plus 5k cap. B vector equal to I cap plus 3j cap plus 6k cap. Find the product of A and A dot B and the magnitudes of A and B. What is the angle between them? Two vectors are given. We should find A dot B, magnitudes of A and B, then the angle between them. Solution. First A dot B, that is 2I cap plus 4j cap plus 5k cap dot I cap plus 3j cap plus 6k cap. I dot I, j dot j, k dot k. Other terms will be 0. So 2 into 1, 2. Plus 4 into 3, 12. Plus 5 into 6, 30. So the answer is 44. Next, magnitude of A. Magnitude of A in the sense square root of ax square plus ay square plus az square. Ax square means 2 square, ay square means 4 square, az square means 5 square. So we can write 2 square plus 4 square plus 5 square. That is 4 plus 16 plus 25. So root of 45 units. Next, magnitude of B. Here also bx square plus by square plus bz square. 1 square plus 3 square plus 6 square. That is 1 plus 9 plus 36. So answer is 46, square root of 46. Next, the angle between them. Angle between the two vectors is given by theta equal to cos inverse of A dot B divided by AB. So cos inverse of A dot B is 44. A, that is square root of 45 into B, that is 46. So we can write cos inverse of 44 divided by the square root. We can write it as 45.5, that is 45.49. So the answer is, dividing this, you will get one answer. And using the logarithmic table, we will get the angle. So cos inverse of 0.967. What is this? In the natural cosine table, we should find the theta value of this 0.967. That is approximately 15 degree. You should use the natural cosine table from the book bag. I hope you understood this problem. Students, today we have learned components of a vector, then vector addition using components, then multiplication of a vector by a scalar, examples, scalar product of two vectors, that is definition, and the properties of scalar product. So learn these questions. Thank you.